So this one is asking us to compare an angular situation to a linear situation, and we're dealing with this idea of change in momentum. So in this case, we are starting out, we have a disk is rotating with some sort of angular velocity, which means that it has a positive angular momentum. And then we place in contact with the wall. We have kind of this force that's acting on it over some amount of time, and it is decreasing its angular momentum. We said, hey, before our change in momentum is equal to our force times our change in time. We have the same thing with the linear sense, that our change in angular momentum, or sorry, our same thing in an angular sense, our change in angular momentum equals our torque over some amount of time instead of force, because torque is kind of our angular analog for force. So then we have this, we start off with a positive angular momentum, and then we are decreasing it. We are having a negative torque over some amount of time until our object comes to rest. So we're just seeing which one of these is the most similar. So block is at rest, and applied force of 3 newtons is applied to the block, but the block does not move. This has no change in momentum, so that's not really helpful. The block is initially at rest. A net force of 3 newtons is applied to the block until it has a speed of 10 meters per second. So that's similar, but kind of like backwards to our situation. This one starts with no momentum and then finishes with momentum. We start with momentum and then finish with no momentum. So let's see with this one. A block is traveling 10 meters per second. An applied force of 3 newtons is applied to the block in the direction of its velocity vector for 10 seconds. So that's not good because this is going to make us speed up. This is going to be a positive change in momentum. And we're looking at a negative change in momentum because we have a torque that's acting against our wheel. So in this case, a block is traveling with positive momentum and then has a frictional force until it stops. So we have a negative force and a negative change in momentum. So this one looks like it is the most similar to what we were working with.